intelligent natural ventilation, key to smart and sustainable building design. I'm Maria Genesi and I will be presenting today. Unfortunately, there has been some last minute changes and I will now present alongside my colleague Mia. Mia has a vast amount of experience within WindowMaster and initially developed our US market. She has since relocated to our head office in Copenhagen to undertake a new role as our Chief Business Development Officer. Thank you for joining today, Mia.
Thanks, Maria, and so happy to be here, everybody. I'm not Tom, and I'm not from the UK, but reach out to Tom if you have any questions about UK projects. I'll try to be as good of a wing woman to Maria as I can, but bear with me if there's any click things. We just had this last minute change. So excited to do this with you, Maria, and follow along as best as you can, and reach out to Tom and Maria if there's questions for the UK or the Ireland market.
Thank you, Mia. So we'll just move on. So here we will take a look at who we are. We are just a small team for the UK and Ireland. This consists of Tom and I, who take care of the project specification. We work with architects, consultants and contractors in relation to the project specification, and we offer design support and pricing. Tom Stevens is our Windows system specialist, and he works with system houses and fabricators, providing actuator design support. And Dale Credland, he engages with our contractors, building owners and managers, facilities and building services, offering service contracts and then refurbishment and renovation works. So we'll just move on to a bit of practical info about today's webinar. The webinar is scheduled to be about 45 minutes with 50 minutes Q&A time at the end. Your microphones will be muted throughout the session, so if you have any technical issues, please communicate these in the chat box. And any questions you may have, please feel free to ask these in the chat box during or at the end of the presentation. There will be some poll questions that will pop up throughout the webinar. Please participate in these by using the voting buttons to gain some insight, feedback and conclusions. So just on the agenda today, we will take a look at the advantages and benefits of natural ventilation, designing for an optimized indoor climate, then intelligent automation for smart buildings, and then some of our WindowMaster solutions that we can offer. And at the end, we will do our Q&A. So here are the advantages and benefits of natural ventilation. Firstly, we have nighttime cooling. This makes use of the cooler nighttime temperatures to lower your peak temperatures throughout the day. This is particularly noticeable in the morning time, just as you first enter the building. We then have cutting CO2 emissions, and this is due to your reduced install and operational carbon emissions in comparison to a mechanical solution. We then have another benefit with safety with smoke ventilation. This is our smoke solutions that provide the ability to clear smoke from evacuation routes. There is then another benefit with app-based control. We have a smart control via iOS or Android for building managers and users that can easily view or make changes to their room that they are occupying for whatever comfort that they need. We then have improved indoor environmental quality. And this is your indoor climate by introducing fresh air and more daylight into buildings whilst maintaining thermal comfort and managing the acoustics. And then another benefit is reduced energy consumption. This is lower energy consumptions versus mechanical solutions, such as an air conditioning system. And with this, you will then get the benefit of reduced cost. This is your lower capital and set of cost, again, in comparison to a mechanical solution. And lastly, another benefit and a great benefit is maximizing floor and building space. With a natural ventilation system, it negates the need for a dedicated plant room and ductwork, for example.
Maria, those are some really interesting benefits, both for natural ventilation systems, but also heat and smoke. But something we also often hear is, well, those are great benefits, but what about the building occupants? You're opening windows. Aren't there any issues with drafts and opening windows in the wintertime? Can you just share a few insights to that? How do we get away from those issues?
So another benefit with the natural ventilation system, and specifically with the MotorLink actuators, which we will touch on a little bit later on, is you can limit your openings through winter months, limit your openings in the winter months. So automated natural ventilation systems allow the windows to incrementally open to a maximum set distance, typically around 50% in the winter months. This is to ensure that the occupants don't feel a sudden draft or there is excessive heat loss, whilst it's reducing the CO2 levels to a comfortable level. This is particularly beneficial in the winter months when an occupied area requires improved indoor air quality.
So you can use it in the winter months. It just
Yes,
depends on what kind of technology you're using.
yes, yes. So
Mm.
we will touch on that a little bit later. So next, we will take a look at the additional benefits then in the event of a refurbishment or a renovation project. So with this, you do have a gentle refurbishment, and this is easily with our refurbishments. We've got control panels that can be concealed in riser cupboards, in floors or above ceilings, and then our actuators are easily concealed from view also. So these could be surface mounted, or we can work with you to design solutions where they are concealed. Our renovations are also quite fast. We've got minimum system components. The wiring can be done via existing cableways and the fitting of actuators to existing windows. With our renovations, there is always the outcome of the high user satisfaction, and this is just due to positive feedback that we've received based on the introduction of fresh air and providing users with the manual override via a keypad that's installed within the space or using the app on iOS or Android. Then another benefit is the low maintenance. Our actuators require only a visual check, and then our control panels require a system health check, probably 6 to 12 months. And with that will come software updates. So, for example, there'll be no need to clean filters and kind of worry about ductwork, anything like that, thankfully. And then another benefit is the green profile and how natural ventilation supports a green building practice and the certifications. Again, we will look at that a little bit later on.
Mhm. Maria, are there any key considerations when retrofitting natural ventilation into existing buildings? What does the audience really need to think about here?
So a key consideration would be the existing window profiles and whether you can mount onto these. So whether you can mount the actuators onto them if you need to work to reinforce the profile, and we can work with you to come up with some sort of solution that we can mount onto the existing profiles. Another consideration will be the cable routes and whether you can utilize existing containment routes or require new surface mounted containment routes potentially. And then another important consideration will be the location of the control panels. You must bear in mind that these must also be always accessible for commissioning and service purposes. So if possible, these are best located in a riser or store cupboard, anywhere that can ensure as little disruption to building users as possible. So that's mainly what you should be considering when you're retrofitting the natural ventilation systems.
Good stuff.
Thank you. So on this slide, we will take a look at the productivity and health benefits when using a natural ventilation system. So these have been extracted from the World Green Building Council, which has published a comprehensive report on health and well-being and productivity in offices. It pointed out that staff costs, including salary and benefits, account for about 90% of the business operating costs. Therefore, staff productivity is a major concern for any organization. So these are just some that we've extracted that is vitally important for natural ventilation. And as you can see, a lot of these are linked to the sick building syndrome, which I'm sure you may all be aware of.
Are there any other known benefits attributing to natural ventilation?
So natural ventilation offers greater flexibility and control over indoor airflow in comparison to a mechanical system. The occupants can adjust windows and openings, the window openings, and utilize passive ventilation strategies to meet their specific comfort preferences and needs. It also creates more of a comfortable indoor environment by regulating temperature and humidity levels. Both of these greatly help in preventing indoor space from becoming stuffy and stagnant. It promotes more of a pleasant and inviting atmosphere to work in also. And another benefit then is there is no build-up of ducted air. So you're kind of removing that stuffiness, which is a great benefit.
Mm-hmm.
So we shall just move on to our green building profile and how natural ventilation can contribute to certification of the building. So firstly, it will reduce the energy consumption and the total overall resulting CO2 emissions. Then you will utilize the free cooling by introducing your nighttime cooling, which we will look at a little bit later again. Then you're reducing the amount of material used in comparison to a mechanical system, which is beneficial for the building life cycle assessment. And then this is also beneficial for the building life cycle cost.
Where can a participant here find out more about using natural ventilation and how it can contribute to BREEAM and LEED?
So WindowMaster has a lot of more information available on our website for both the BREEAM and LEED certifications. We have a dedicated page for each of these. There is also a link in the handout file section, sorry, within the webinar where you can download our ebook, which also contains some more information how we can contribute to the BREEAM points. So you can extract that from there if you like, but also refer to the website.
I can post the two links to the one for BREEAM and the one for LEED into the audience chat.
Yeah.
So you guys have the capability to get to both of them. I've put the links into the chat.
Thank you, Maria.
So please refer to that. And then, as Maria said, there's a section up top where you have chats. Then there's also a handout section, and there's an ebook on natural ventilation attached there. So if you open that handout and do a search for BREEAM, there's also a section in there. So use either the ebook handout or the links that I've just posted into the speaker chat, or I'm sorry, the audience chat.
Thanks, Mia. So here we will have a poll question.
Fantastic. So I am going to go up and launch a poll for you guys. The poll is about how often are you seeing projects specified with natural ventilation, specifically for window automation. I am going to go ahead and launch this poll now for everybody to participate in. When it's launched, then Maria is going to give you guys some insight into this project that's shown on the shared screen. And when she's done explaining the project, then we will launch the results of the poll. So I'm going to go ahead and start this, and then you take it away, Maria.
Thank you, Mia. So this is Space House. This is our recently commissioned system in London. It's a Grade 2 listed building that was built in 1968 in central London, and it's being refurbished to provide leased offices and a flexible retail space. It's the first of its kind of the smart office building in the UK, with strict CO2 targets aiming to achieve BREEAM Outstanding and the Fitwel 2-star certification. It features our MV embedded control solution with CFD analysis and to optimize the window openings across each of the facades. The users can access a central app interface to control the indoor climate and manually override the windows. So this doesn't have any keypads in it. They do it via the app only. This is a lovely building. Some of us have been lucky enough to go and visit so far.
Very cool. And you said it was a refurbishment, right, Maria? So it's not
yes.
a
Yes, no, this is a refurbishment. So they stripped out the entire interior of this building and yes, refurbished it to a new office development. So it's really nice, one of its kinds, and I'm sure we'll be seeing a lot more of this coming up.
Yeah, and super important to highlight that it doesn't have to be new build to include very advanced technologies such as something like intelligent natural ventilation. Using the current space for building stock that we have out there can include something like automated natural ventilation. That's really good to see. I'm gonna, anybody else have a chance to answer the poll? I'm just gonna give you 5 more seconds. And then I am going to close the poll and then let you guys see what your answers were. So how often are you seeing projects specified with natural ventilation, window automation? Not a lot, sometimes, rarely. It's not never, but it's more on the rare than the sometimes.
Okay.
Good to know. Thank you all for participating. It's really insightful information also for us to see stuff like this.
Yes, thank you. So next we will move on designing for an optimized indoor climate. So here we will take a look at the geometry of space and then the ventilation principles. So with your ventilation principles, you are looking at single-sided ventilation. This is suited more for a low occupancy space. This would be like a small office room or a small meeting room. With cross ventilation, this is preferred for a higher occupancy space. And then stacked ventilation is ideal for high occupancy or foyers or atriums, as you're drawing the cool air from low levels and exhausting the warm air through the high level openings. With smoke ventilation, the stacked ventilation is the ideal solution here also.
Maria, for a building in the city, the center of a city, how do you propose ventilating the low level floors exposed to noise? So cars going outside, buses, people, and also things like air pollution. So if it's located there, how do we make sure that natural ventilation, how can it be used if we're in a city center area where noise and pollution may be a concern?
So you could install high-level windows on the quieter sides of the building to draw in the fresh air while minimizing the exposure to street-level noise and pollution. And you will see this probably more so in like the London, Dublin, Cork, where we're getting a lot of more of the built up area too. But where required, you can utilize mechanical systems such as fans or ducts to distribute the fresh air to the lower floors where natural ventilation may be limited. So that is one way that you can propose ventilating the low level floors.
So the last one you talked about is more of either a mixed mode or kind of like this hybrid approach.
Yeah,
You use the mechanical when it's required, and then you can use the natural ventilation where it's also possible. It doesn't have to be 100% natural ventilation or nothing at all.
yes, exactly. And we easily interface to the mechanical systems to enable or disable where required.
Great.
Yes. So now we shall take a look at the key benefits and principles of night cooling. So firstly, with night cooling, it does reduce your daytime use of the mechanical cooling systems, and this is an important factor because you're incorporating you're allowing the building to breathe at night, and it can reduce the temperature of the internal fabric and contents, with the potential to reduce the peak daytime temperature by up to 10 degrees. So this again can lower your energy bills, which everybody likes nowadays, and it can enhance your performance of the building envelope as a whole. And again, it will improve your occupant health and comfort, as we had looked at previously on their productivity and health benefits. And then lastly, you will have your low carbon method for building cooling also, which is another key benefit and principle of night cooling.
But then what about you're using night cooling, which means opening the windows at nighttime? Some people might think, wait a minute, I'm not going to open my building at night. Isn't there a security issue with having windows open at night?
Yes.
To that.
Yes, so security is an important factor and concern, and the key is to set maximum opening distances and having positional feedback from your actuators. So with WindowMaster, we do apply a common sense approach to limiting the openings based on access. So for example, the ground floor vents, they would remain closed and the levels above would be used to cool for nighttime cooling. So actuators are set to restricted distances, which can be reduced or increased based on the floor levels above and the cooling requirements for that building.
So just like you showed in that image on this
Yeah.
shared slide, the automated windows are at the top, and those are the ones then you maybe maximize the opening to a small amount, but still allowing that fresh, cool air to come into the space, and therefore the occupants have a fresh climate to come into in the morning.
Yes, exactly. So next we will just look at the optimum window design. So for optimum the window design, high level vents would be preferred, and we would suggest that these be 2 meters or more above floor level. And we would also, ideally, these would be top hung outward opening for an unrestricted airflow. Significant clearance between the vent and the ceiling is also should also be considered. Apologies, particularly on the inward opening vents, and this is just due to reveals and low ceilings that could potentially restrict your airflow on the inward opening vents. We would also suggest to evenly distribute the openings. This is just to make use of your triangles on either end of your openings on the hinge side. And then with your window height and width, this is kind of the general rule if you are looking to install one actuator on your window. But if you were to exceed these dimensions that we've stated here, we will just increase the number of actuators that we would install on that profile. So you're not limited to just one actuator per window.
Your image here, Maria, on the shared screen shows us the top automated windows, the light grays there, as you write, distributed. So not a bunch of windows automated right next to each other. We have architects also on this webinar today, and for aesthetic reasons, mostly what I always hear is that then it's made a decision to do a long bank of automated windows, not this distributed one window automated, one not, one window automated, one not, but preferred to do a continuous bank of windows. That is a great aesthetic approach, but how does that affect the airflow into the space, Maria?
So with the continuous bank of windows, the airflow within that space would reduce as you're removing the airflow that would be included from the hinge side, so the triangle sections on each opening. So effectively, you will be just able to account the airflow on the triangle side on either end of that continuous bank of windows. Whereas with the image on on display at the moment, you would have the airflow from both of the triangle sides rather than just at either end of this. If that makes sense.
So pros and cons to, of course, they got to weigh between the aesthetics of having a long bank of automated
Yes.
windows, but also you want to maximize your free opening area to get a good amount of airflow and air change rate in the various rooms. So something to consider. It's not to say
Yes.
that you cannot have a bank of automated windows, but just something to consider and to review with the consulting engineer about how much opening do you actually need.
Yes, yeah, and the airflow for that particular space. So we should move on. So here are some other benefits of optimum window design. Just for the high level vents, these are safer as they are out of reach of building users and therefore avoiding any entrapment. They're more secure as they restrict your access during the day and at night for the nighttime cooling. They are a better performance as they're allowing the cold air to mix with the warm air at a high level before it actually reaches body height. Therefore, it's avoiding the perception of drafts also. And then it is a lower cost and more effective than a louver as it provides better air tightness also. And then with drafts, automating them high level vents, as we just explained, it does reduce the occupant feeling the immense kind of draft if the low level vent was to be automated. So with the low level windows, you can leave these as a manual operation. This is what we would suggest. It increases, sorry, apologies. It increases your opening area for thermal comfort, and then it allows more manual override from the building users. But it also reduces the total number of actuators that's required on the building, so it keeps your costs down as well. So it's another benefit.
But we hear also the concern or sometimes the question about, okay, we're using automated windows. What if somebody or something becomes entrapped while the window is operating, traditionally while it's closing, automated? What if you have concerns about entrapment with using automated windows? It could be a school building or a place where there's a lot of offices where a lot of people are. What options are available to when the architects and engineers talk to the building owners to kind of ease or adhere to those concerns?
So pressure safety strips, also known as safety edges or safety sensors, would be what we would suggest to overcome the entrapment issue. So these are devices that are used in automated window systems to enhance safety by detecting obstructions or pressure that's exerted on the window during operation. The strips typically consist of a flexible material such as rubber or silicone, and they're embedded with sensors or switches that can detect changes in pressures. And it requires a specialist version of our motor link actuators to automate these windows also. But these are quite good for particularly school windows. If you're automating low level vents, we would always suggest to install these pressure safety strips.
Good stuff.
Now, so just as we move on, we will have a look at the operable window types. So you can nearly automate all types of window openings. The distance, angle, or free area achievable is determined on the opening orientation and the vent size, and then also the window profile. But as you can see here, we aren't really limited to what we can automate, and we have solutions for concealed and surface mounted actuators. If you would like to discuss any of these.
Are you limited to any type of window profiles you can automate? Like, can it be timber? Can it be UPVC, aluminum? What kind of material can the windows be made out of?
So there may be some differences in the automation process based on the type of window material, but the advantages in the automation technology have made it possible to automate various types of profiles, including timber, UPVC, and the aluminium. However, it's essential to consult with a qualified window system specialist just to determine the most suitable system and the specific window type and design that you're looking to work with for your project.
So it also depends a lot on how secure the brackets for the actuators can fasten to the different type of materials. Maybe
Yes.
additional fasteners or closing hinges or material needs to be added if they want some type of material compared to another.
Yes. Yeah.
Good to consults. And your screen here shows, fantastic what kind of options are available, and that we definitely want to focus on. But to also focus our attention, sometimes it's good to say what we cannot automate. So Maria, what kind of window types or profile types do we not have an automation solution for?
Unfortunately, we cannot automate the tilt and turn sash. This would either be the tilt or the turn option that we could automate, and then we also would not recommend automating a sliding sash opening. We have seen some of these automated, but aesthetically they aren't very pleasing. So we would always advise against automating the sliding sash also. So really, we can do most profiles, thankfully.
Cool.
And we shall move on. So just with the actuator aesthetics, as we were explaining, there is concealed and surface mounted options. So if you were to have your actuator surface mounted, we do also have the ability to powder coat these in any color that you may want, any raw color that you may want, on your project. Sorry, this slide has gone funny. Apologies. So yes, they are surface mounted or concealed. And then there is also a way that we can conceal the actuators with a cover cap. And this is what we're seeing coming up on a lot of our projects going forward and in recent years also. So rather than concealing the actuator completely in the frame, the fabricators are working to prepare a cover cap so that they can just mount this over the actuator, conceal, and you would not even know that the actuator was there.
But fantastic to be able to conceal the actuator. But these are devices which are electronic devices, so they have cabling. What about the cabling options, Maria? How can, again, thinking aesthetics for our architect friends on the call, how do we conceal that cabling as well, or what recommendations do we have?
So concealing the cabling in the automated systems is feasible, and it can be achieved through various methods, including built-in channels, recess mounting, concealed housings, or customized solutions. You can also have a surface-mounted trunking that could conceal the cabling also. But by concealing the components, that being the cable and the actuator, the automated windows can seamlessly integrate in the architectural design while providing the enhanced functionality and convenience that is required with window automation. So we can work with the designers in order to achieve what they are looking for aesthetically as well.
Fantastic. Good to hear. And also a good thing to note is that collaboration effort with the fabricators or the installer on how this work is going to be done, not only aesthetically, but also, who's going to do it.
Yes, we're happy to work very closely with the design element with architects and fabricators on the profiles. So we shall just move on. So we have a poll question, Mia?
Yeah, we do. So next poll question is, what is the most important consideration when choosing a suitable actuator? And I'm going to launch the options here. I think that makes more sense than saying it out loud. While I do that, Maria's got a fantastic reference case to talk to you guys about. Maria, I'm going to hit start, so you go ahead right now.
Thank you. So this is our St. Mary's Voluntary Academy in Derby, and it is the Department of Education's new school design. It is the country's first biophilic school with net zero carbon emissions, focused on being close to nature and deliberately connected to outdoor spaces. It again features our MV embedded control solutions with a cloud-based user app and FM dashboard. The teachers are able to control the indoor climate and manually override windows via the Android and iOS app. And then the BMS interface is for sharing window positions and sensor data to avoid doubling up of sensors. So they've removed their CO2 sensors and are purely relying on ours.
So this is a new build project?
Yes, this was recently handed over as well. It's relatively new as the Space House one. I think this was done in the last few months, to be fair. Another one of Tom's. He's a bit more information on this one, unfortunately.
No, that's okay. Anybody who wants more information on St. Mary's is welcome to reach out to Tom afterwards. And just a few more seconds. What's the most important consideration when choosing a suitable actuator? Is it aesthetics? Is it noise? Is it level of control? Or is it all of the above? I am going to close the poll and let's see what you all said to the question. Ready? 1, 2, 3. Oh, drum roll. All of the above. What do you say to that, Maria?
All of the above. I was expecting that, to be fair. I did think that it would be.
Thanks
Thankfully,
for
we do. Thank
thanks
you.
for everybody's participation there. I'm going to close this down.
Now, and we shall move on to intelligent automation for smart buildings. So what is an automated natural ventilation system? So here is just an image of what makes up an automated natural ventilation system. There are basic components of the natural ventilation systems, and the head end can either be the BMS or standalone NV controlled solution. Then there would be indoor sensors, which is monitoring the temperature and CO2 levels throughout the day. Then you will have outdoor sensors, which is our weather station that monitors temperature, rain, wind speed, and possibly wind direction, which is based on CFD analysis. You then have heating control, and this is where it's ensuring that heating is not engaged when the windows are open. So this is purely kind of when we are interfaced to a BMS system.
But you mentioned that we have an outdoor weather station or outdoor sensors, but does that mean that do you still open then the windows, the automated windows when it's raining or high wind, or how is that controlled?
So if ventilation is necessary during such conditions, it's important to use the appropriate methods and precautions to minimize potential risks and ensure the comfort and well-being of the occupants and the property. So by using the incremental openings or trickle ventilation, this ensures controlled airflow while minimizing exposure to wind and rain. So ultimately, this is the decision to open the windows during inclement weather will prioritize safety, comfort, and the protection of the indoor environments from draft, moisture, and debris that may come in from the external conditions. So again, it won't throw your windows open to, let's say, 100%, and this is because you've got the ability to set your distances with the natural ventilation systems.
Yeah, here in Copenhagen, Denmark, where I am, where it rains a lot of the time, and I'm sure in the UK and Ireland, you still want to be able to have some fresh air into the space,
Yes.
right? So just tiny openings,
Yes.
even, but the windows we have here, which are the opening, the automated ones that are right above where I'm pointing to, they also have an overhang. So there's also design considerations in addition to the weather station that you can add in to make sure that you still have the capability to open a little bit. Automated, of course, not manual, because or else people forget to close the windows.
Yes. So yes, it can help.
Yeah.
Now we shall just move on. So this is an automated natural ventilation system and the components that will consist for comfort ventilation. Now we will just look at an example here of an NV, standalone NV control solution. So here in the middle, you will have your control solution, which will link to a motor controller. You then have actuators on each of your openings, which will feed directly back into your motor controller. So each of these will be cabled back to your motor controller. Then your sensors and keypads, again, will go directly into the motor controller, and this will relay all of the data to your NV control solution. And here you will have your weather station, again, which goes back to the motor controller, and this will relay all of the information to the NV controls, which will then feed this on to any other slave motor controller panel that is within the natural ventilation system. So as a whole, this is what the system is made up of. It's minimal cabling. As you can see, if you had your motor controller locally installed to kind of one area within the building, that will minimize your cable runs for each of those areas as well. But again, we can assist with any system designs just to reduce your cabling, the number of control panels that may be needed with your system designs also. So here we will look at the components for a comfort ventilation system, but if this was under BMS control. So this does differ slightly from standalone. So here you'll see in the center, you've got your building management system. This is going to be the brains of the operation, and the weather station will feed directly into the building management system. Your sensors are also going to fit directly, in there. My animation seems to be slightly off, my apologies. But the BMS will relay all of this information to the WindowMaster motor controller. So we're relying on the BMS for the weather data and then the internal CO2 levels and temperature levels. Your actuators will go directly back to the motor controller. And this is where we will operate the actuators based on the conditions from the BMS head end. So as a whole, this is how the system is made up and where who is responsible for what when it comes to interfacing to the BMS control. But again, we will work very closely with architects, consultants, BMS engineers when coming to designing a natural ventilation system under BMS control. And lastly, we will take a look at the system components that's required for smoke ventilation. These will differ again, and the cabling for this would need to be FP rated for a cable, and your smoke control panel would also be slightly different to the motor controller panel. So you would need a direct link to the fire alarm system. Now, smoke detectors would tend to sit on the fire alarm system with the brake latch units terminate directly into the WindowMaster smoke panel. Actuators again are wired directly back to the smoke control panel also. So it's again minimal cabling, and these can be located in various places around the building. Again, they would need to be accessible for service purposes. So just some top tips then and final notes when it comes to designing for your optimized indoor climate. For your optimized indoor system. Consider your optimum window position and your openings. Don't forget to consider your wiring routes and containment and even your actuator concealment. We would always suggest to use smart actuators with intelligent incremental and percentage control, just to maximize the ability to control your windows and the airflow into the spaces that you want to automate. And we would also suggest to engage with an expert as early on to avoid any of the common pitfalls and to ensure a robust design when it comes to delivering your project. So lastly, we will have our final poll question.
Final poll question, everybody. What concerns do you have with specifying a natural ventilation or window automation? Curious to hear what you all think about what concerns do you typically have. While I launch that right now, Maria is going to talk about Plot 9A.
So Plot 9A 4th Street is located in Manchester. It's a new build net zero office development, and it's committed to achieving the BREEAM Excellence standard with an EPC rating B. The ground floor is flexible amenity space with 9 upper floors of open plan and flexible office spaces. This features the WindowMaster MotorLink actuators and controls, enabling BMS control, and it makes use of over 1,200 surface mounted actuators with over 50 concealed actuators fitted in parallel openings. So we control this building using 70 of our WCC 320 control panels, which is interfaced via MSTP to the BMS system. So we do have many ways that we can interface with BMS also with MSTP, KNX, or IP. So we're not limited to how we can interface all of them. Yes, so this is actually another recently new building also.
That was going to be my question. Is it we're completely done with? Or what's the status of the project?
Yes. Yes, this is a new build that has been recently handed over, I believe. Again, the projects that we featured throughout this are all of our most recent projects that we've completed. So I'm sure you'll see plenty of nice photographs of these going up on social media.
And do you have just curious for my sake, Maria, is it a mix of the ventilation principles for this project, like stack, cross, or is it a lot of single-sided? Because this is an office space. Are they doing more open or closed spaces where the natural ventilation is used?
So I believe that they're applying a stack ventilation solution here because it's more of an open planned office as well. So it's a mixture of kind of cross ventilation with stack ventilation where it applies.
Great. All right, everybody, you've had time to give your answers to what concerns do you have with specifying a natural ventilation or window automation project. I am going to close the poll and let everybody see the results. What do you say to that, Maria? Does that also sound familiar? Is it something new about this?
Surprising, to be fair. Good. Yeah, I'm quite surprised. Yeah. If anybody would be happy to share their other comments, we would love to see what that is. If you'd
Mm.
like to include that in the chat.
Yeah, please put it in your chat. What are the when you're thinking of what other concerns do you have? If you can write them in the chat, give that a go there. We'd love to hear what your other concerns are that we haven't listed there, and we can go through that at the end if there's also time.
Yes.
All right. Thank you, everybody, for
Thank
participating
you.
in our 3 polls. Closing that
Yeah.
away, Maria.
Thank you. They've been great. Very insightful. Thanks, guys. So just another couple of tips that we have here, and some solutions that we can offer throughout your design. These are some free to use design tools that's available on our website. We will include the link to our website at the end of the webinar. But we just have dimensioning tools that you can use, air change rate calculators. There's actuator finder that you can pop in your details of the profile that you're potentially going to use on your project and just see what actuator we may suggest, the number of actuators, the airflow. There's a lot of detail that you can find on our website. You can also join our webinars. You can have a look at our ebooks, our older white papers. There's a lot of informative information available on our website as well. So just another solution that we had briefly touched on earlier on. So this is intelligent automation with MotorLink. So MotorLink is a technology to WindowMaster with WindowMaster actuators. It's painted to WindowMaster only. And we will just go through our 5 benefits of MotorLink technology. So firstly, with MotorLink, you have the ability to synchronize your facades. So you can set your opening on one facade to a maximum of 50% so that nobody can open their windows past this, so that you've got one uniform facade with all of the openings at the same opening distance. Now this as well with the synchronized dynamic facades, when you have multiple actuators on a window profile, our actuators come with a third cable, which allows communication between each of the actuators. So in the event of failure of one actuator, if you've got multiple actuators on one vent, if one was to fail, the rest of the actuators that's on that profile, they will cease operation. And this is to eliminate the risk of the vent still opening and potentially damaging your profile or burning out the actuators. So this will feed back any information to our control panel to say, I'm kind of faulty and I'm not working. You need to come and investigate me. So we'll cease the operation of the vent, which is a really good benefit with MotorLink. So again, I've just touched on it there. It's your accurate control and feedback. So this is then feedback of the position. Again, if it's faulty or when it's in operating position. So you will have real-time feedback during operation, whether it's open and closing. You will see that in real time on the control panel on our head end or the BMS head end. You then have whisper quiet operation. MotorLink is built in with 3 speeds of operation. So it's not silent, unfortunately, but it is near silent on the automatic speed. So with the automatic speed, the audible levels for this, they would not really be noticeable when you're in a busy working environment. You wouldn't really hear the window operating. Manual operation then would be our second speed. This is slightly more audible, and it's just so users in that space, if they don't have a visual of the window that they are automating, it's just so they can hear that that motor is opening and it's operating the window, just again so that they don't kind of persistently press on the manual override keypad, potentially damaging it. And the third speed that we would have is for smoke and for rain. So this is our fastest speed and most audible speed also. But again, it will close your window within 60 seconds. So it's quite loud, but not too disruptive. You then have safe operation, and this is where we have a pressure safety function built into our actuators. Now, it's not to be mistaken for anti-entrapment, it is purely just a pressure safety function. And this is where the actuators have the technology to reverse the operation if they feel an obstruction on the outer section of the sash. So in the event of installing on a low level window within a school, you would again be recommended to apply an anti-entrapment strip on these. I wouldn't purely recommend kind of relying on the pressure safety function in this instance. And then lastly, With the MortLink technology, this is an easier installation and it's more reliable for data feedback on the BMS head end, as well as the MV control solution. But you aren't limited to this technology with just a WindowMaster MV solution. It is available on the BMS also. So if you'd like to explore more of our projects, we've got many other examples on our reference page on the website. Again, you can go through these. We've got them kind of filtered out to each of our markets. There's many projects that we've delivered in all the markets that we've got our offices in. So there's a lot that you can have a look at, and many different types of projects that we've worked on, different settings, skills. There's a lot of information that you can take a look at there. So question time, Mia.
Yeah, absolutely. Thank you, Maria. That was a fantastic presentation. Thank you for that. One of the first questions that popped out, which I wanted to keep all the questions to the end, but somebody asked if we are able to send the presentation. So of course, this recording will go directly to their email afterwards, but are we able to send the presentation to Gia de Sunday? If I pronounce the individual's name correct, they would love to have your presentation.
Okay, thank you.
Yeah, you're welcome.
Yeah, I will take a note of that, Mia.
Yeah. And then another individual asked, what solution do you have for wet room ventilation?
For wet room ventilation.
Wet room ventilation.
Well, the design for this would kind of need to be, the IP ratings would need to be considered for this. We need IP rated enclosures to conceal control panels, but again, you would need to be considering the condensation within this space and how this will potentially damage the actuators over time. You may then run the risk of having to replace actuators frequently due to excessive condensation. But again, you can engage with us following the webinar, and we can kind of look at design solutions that we could potentially offer in that type of project. Mia, would you have anything to add there?
I would just say without a cover capability or anything, the average IP rating for our actuators, they depend on the specific actuator type, but they go from, up to 42, I believe, IP, but I can't remember what the lower IP rating range is.
20, yeah, I believe it's 20, yeah.
And then, of course, there's things that the installer, the fabricator can do to help the framing, but the actuators themselves, of course, also have an IP rating, and they differ also on the actuator type. So ask Maria or Tom which specific ones are maybe the higher ones, and will they fit for your window configuration, dependent on your project.
Yeah.
But yes, I would say the main thing to consider is how much condensation is. You can see that in our data sheets for the respective actuator, also what we recommend for the highest precipitation rating percentage. So there's also a note about that in each of the data sheets. So take a look at the data sheets that Maria and Tom send you. When they recommend you the actuators, you'll also see the precipitation. I think it's called operation conditions or something like that in the data sheets.
Yeah.
Cool. And then in the questions section, when you were talking about the components, so here at the end, the natural ventilation, what is an automated natural ventilation system, and then went into the components, both for the standalone, the BMS, and then for the heat and smoke system. An individual Alfonso asked, are the system components connected by wired, or are they wirelessly?
Yeah, so unfortunately they're wired. We haven't developed a wireless technology just yet. I don't envision that to come anytime soon. So yes, they are wired for now. And then the solution, I just see another question here, is that solution MV embedded? So the system components is just based on our NV embedded solution, but we do have another solution, the NV advanced. But the NV embedded is kind of the solution we would suggest going forward. It's our more advanced, and we've developed our technology using the app and the smart system developments with iOS and Android. So does your technology utilize machine learning and intelligence, and is it be embedded? Sorry, I'm just looking at the other question that's popped in here. Machine learning. Yes, Mia, so would you like to take this question?
Yeah, so the NV embedded control system is algorithmically controlled. So in WindowMaster, our product management and R&D department has developed our own sequencing, our own algorithms. They are, from as far as I understand, but I'd love to follow up, and Alfonso give you a direct email reply via Tom and Maria once we've checked with product management. But I wouldn't say the technology incorporates any levels of deep machine learning. It is, but it is algorithmically. So dependent on all the inputs, right? All your outdoor weather station sensors, sequencing from other systems such as BMS or fire safety. But the system, as I am aware at this current time, doesn't necessarily learn from itself and therefore makes tweaks on its own. But Maria and I can definitely take a second triple check with product management, maybe can give you some insight into what's to come if there is any news there.
Yeah.
And I don't know if it's a heuristic approach. I'm not too familiar with the terminology there, but we'll write your question down, Alfonso. I think it's a little bit more technical than I'm able to converse in, but we can definitely check and get back to you in an email. We have your email, Alfonso, and Maria can get you a response as soon as possible to that question. Unless you know, Maria, sorry, I definitely shouldn't take that away from you.
No, we will need to consult with product management on this one, Mia.
Yeah. Great. Thanks, Alfonso.
Yes, thank
It's
you.
great to hear that you're studying these kinds of technologies, and we'd love to converse more with you about that.
Yes.
Great. Question that I had, Maria, let me just check if there's anybody else in the chat. You have presented, of course, a lot about natural ventilation systems, these automated systems, both for natural ventilation, but also for heat and smoke. So say a project wants to initially use facade or window automation because they need a fire life safety design. They want some free opening, and they see the facade as an opportunity. So they initially buy the actuators, the control panels, and they design it in just to use it as a fire life safety design. But then say, creativity gets going, the architects are on board. The actuators and the automated windows that have been designed in to be purely in the beginning heat and smoke purpose, can they also use them as a comfort ventilation? So during the day, could they use the same actuators to do comfort, natural ventilation, and then also have them be part of a fire life safety system?
Yes, yeah, you have the ability to do that with our comfort compact smoke control panels and then our flexi smoke control panels. So you do have the ability to control for comfort ventilation in the daytime, but then have the smoke ventilation and backup batteries in the event that it's required.
Cool. I think it's something that when I would often talk to architects and engineers, it's a way to divide your upfront capital cost into different budgets.
Yeah.
It's in the beginning, it might seem like it's a different technology or something else to use if it's natural ventilation. But if you can also divide the upfront capital costs into fire life safety, then you're able to spread that budget a little bit easily and have a different return on investment story to give to the ownership or the developer.
Yes, yeah, we do have a couple of projects that I've delivered in the UK where we kind of use that strategy for comfort and smoke ventilation in London and Scotland, I believe they are. Cool. So we do have a few of them, yeah.
Fantastic, Maria. Anybody else have any questions? Please put them in the chat or in the questions section while we have Maria live on the line with us. We'll give that just another 30 seconds while you all are putting them in. Please also remember there is the handout section here. And in the handout section, you guys all have a free download to an ebook on how to design natural ventilation. And then there's also another handout, which is specifically about WindowMaster's MotorLink technology, which is something Maria presented on at the end. These key types of features in our actuators that differentiate us and are strong to use in projects, especially when you have building occupants and owners who have some concerns about, again, draft, noise. You need these actuators to be smart and to control in a smart way. And that's where MotorLink comes in. It can do different speeds, you can do different levels, it can come in different noise levels, therefore, and integrate in a lot of different ways. So please download those. And we have a question again. Alfonso, what is the name of the sensor products you have? Indoor sensor, temp and humidity, and outdoor weather station, if you have a proprietary.
So these are WindowMaster products that we have procured specifically for ours. Mia, do you?
I don't know what they're. We can send you the data sheet, Alfonso,
Yeah,
in addition to that for the outdoor weather station. So the WOW 600 for the MV embedded system, and then or also just the wind and the rain sensor.
yeah.
And then our indoor sensor is the WWS 100, which includes CO2 temperature and relative humidity. And maybe there's another one you use in the UK or Ireland that I'm not aware of.
Yes, the wet 112.
The wet 112, okay.
Yeah,
But they in the data sheet it's labeled, it is a WindowMaster sensors.
yeah.
So but maybe there are some technical details in the data sheet, Alfonso, that you can find
I'll send
outside
them.
of our data sheet as well that can correlate. But if you would still like information, of course, Maria and I can go to product management and ask more about them as well. So we've got you covered for that question and send you those data sheets, Alfonso, in addition to the machine learning approach to NV embedded. Yes,
Yeah.
we'll send you an email. Great.
Yeah. Well, thank you, Alfonso.
Yeah, nice. I think that's it, Maria. We are also nearing the end of time.
Yeah.
Great presentation. Thank you all for tuning in. It's been lovely to see the participation around in the polls and in the chat.
Yes, thank you, everybody.
Yeah, I think that's it, Maria.
Yeah, cheers, guys.
All right, thanks, everybody.
care.
Email will come out an hour after. I think it's maximum an hour after. You'll get it directly to your email with the recording. And you should also, in the email, you will have Maria's email and Tom's email. So communicate directly with Tom and Maria if you have questions concerning the UK or the Irish market and anywhere else. WindowMaster.com contact section. There are also other markets that we're in, but please contact Maria and Tom for the UK and Ireland. Thank you all for participating.
Thank you.
Bye, Maria.
Bye, guys. Bye, Mia.